Okay, a growth mindset math Panthers. This is the thing. Welcome to part 2 of packing cubes lesson. Packing cubes, packing fractional length cubes into rectangular prisms. That's what this is all about. But this is part 2 where we're going to we did multiplying before, so what do you think we're going to do here? Before we multiplied, right? We said, well, if you, how many cubes will actually go into this big box? Now we're saying, here's the number of cubes. We're giving you how many cubes. How big is the box, the big box? So we want to know how many small boxes before. Now we're going to say, well, how big is the big box? All right, let's do this. So remember, here we have every 8 cubes that have a ½ inch length make 1 cubic inch in this case, or 1 cubic unit. Oh, why does it say inch? This should be centimeter. I better be consistent here. Let's just change this to centimeter. Although the problem says inch. So maybe we should change the problem up here too. At any rate, just say units, whatever the units are. Let's just go with this. All right, so 8 cubes make up the unit that we're looking at. How many do we have? We have 16. So 16, it's like a ratio. So for every 16, for every 8, for every 8 cubes, the little ones, for every 8 little cubes, we have 1 cubic unit, 1 unit cubed. So these are the little ones, the little things in this case, because these are the half inch. Okay, in this case, they are 8. So 8 for every one, but we have 16. So how many down do we have down here? Well, how do you go from 8 to 16? Multiply by 2. So multiply this by 2. So 2 is the answer. That's a way of doing it. Or we could also look at it this way. Every 8 cubes that have 1/2 inch length equal 1, just cubic unit, unit cube, whatever the units are. So just whatever they are. Just they have to be the same, of course. So that's 8. 8 and 8, 16. So 16 cubes with a ½ inch length equals 2. So the volume is 2 cubic inches in this case, if you have this problem, giving that, of course, that these are inches and not cubes. Okay. So what are we doing here? So if we have 8, we have 1. If we have 16, we have 2. What if we have 32? What's the volume of that going to be? If we have 32 little ½ inch of these, 32 of these things, basically, how many of these will we have? Well, okay, just double, right? 8, 8, and 8, and 8, 32. So that's 4, right? That's the volume. That's the answer. What's the volume when you have 32 little cubes? Because you have 8 little cubes in here, 8 little here, 8 little here, 8 little here, and you get a total of 32. Okay. What about 48? 8, 8, 8, 8, 8, 8. Is that 48? 8 times 6 is 48. Yeah, 6. Okay. So these dimensions, by the way, just to kind of bring that, this is be a 3 by 2 by a 1, right? Okay. Or you could also have a 2 by a 3 by a 1, and that's going to give you 48 little tiny cubes. Okay, so 6 big cubes, which are our unit length, 1 by 1 by 1. Okay. So what if we have 80? 80 little cubes. What will the volume be? In other words, how many of these boxes, these bigger ones, the unit ones, will we need to get 80? Think about that. It's 10, right? How do we know that? Okay, and what are we really? We're measuring out. That's what we're doing. We're measuring things out. 8 cubes at a time. 8 and 8, there's 16. 8, so on. 8, 16. So you put your 8, 16, and your 24, and your 32, and your 40 all about. Your 48, there's our 48. 48 and 56 and 64, 72, 80. 80, that's the 10 one, right? Okay. So we're dividing. That's what we're really doing. We're saying 8 divided by something gives us 1. 8 divided by something, no, 16 divided by something gives us 2. What are we dividing by? 48 divided by something gives us 80 divided by something gives us 10. In this case, we're dividing by the fractional cubes per unit. Divide the number of fractional cubes. So the number of fractional cubes in this case is 80. Divide it by the number of fractional cubes per unit, which in this case is 8, right? Because 8 of these fit into one of these. Okay. So this is the formula. It's T divided by F equals V. So if you want to know the V, you take the T, which is the total number of fractional cubes that they give you, divide it by F, which is how many fractional cubes fit in a unit cube, and you get the answer. So this would be 8 divided by 8 is 1. If you have 16 total cubes, it'd be 2. If you have 32, it'd be so on and so forth. Just divide by 8 each time. So the answer in the chat, I think we already did. Oh, 88. Oh, what would you have if we have 88 half-inch length cubes? What would the volume be? We could fit 88 half-inch length cubes into a box. How big is that box? Pause. Oh, you're back. Did you say 88 divided by 8, and did you get 11? Yeah, I knew you would. I knew you could do it. Okay, let's try this one. This time we have a prism filled with 81 cubes, right, that have a 1/3. Oh, you remember that? So you got to know 1/3. Well, we know the 81. Whoops, that's the total. So we know we have 81 divided by something gives us our answer. So what is basically just how many 1/3 fit into a 1 by 1 by 1? If you got that, you're good to go. Okay, 81 divided by, do you remember how many 1/3 fit inside of here? I feel like the M&M commercial. I can't believe it. No, but actually that'd be if I were trying to fit this in here. Oh, there it is. I revealed it. I think I just revealed it there. That's cool. I didn't mean to do that, but that was a nice happy accident. As Bob Ross says, we don't have accidents. Or mistakes, that's what it was. We don't have mistakes, we have happy accidents. And just in the spirit of Bob Ross, I'm going to put a nice little happy smiley face on this guy. It looks like Marshmallow now, right? Or Division Man, remember when we were doing that? Okay, I'm getting distracted here. 1/27th, okay, so 27 equals, oh, gotta divide. So I like the strategy that somebody told me, I think it was Alyssa Serrano. Oh, can't say last names, Alyssa. And she had this really cool idea where every time, I think I did this when I was in high school, when you do something like this and you have to multiply, she always liked to do this strategy. Whatever it is, multiply it by 5. Because 5 is in the middle of all of this. Because what are your options? You can multiply by, let's see, you can multiply 1, 2, a 3, a 4, a 5, a 6, a 7, an 8, or a 9, right? Those are your options. So her idea, which I think is brilliant, or I don't know if you learned it from somebody, either way, it's still cool. I love it. Do the 5 first, because then if you get a number that's smaller, let's see, smaller, too small, then you go this way and pick a bigger number. If you get a number that's too big, go this way and pick a smaller number, right? Let's try it. You'll see what I mean, I think, I hope. So 7 times 5 is 35. 5 times 2 is 10 plus 3 is 13. See, now this is too big because we need it to be 81 or less, right? So we can eliminate all of these. None of these numbers are going to work because if 5's too big, the 6 is going to be too big. 7 is going to be, all these are going to be too big. So it's got to be one of these. So now you can kind of start doing a little bit of guesswork and thinking, okay, if 5 gives me 135, I want to get something to 81. That's like half of that maybe. I don't know. I could try 3. Should I try 3? Let's try 3. 27 times 3. So I'm going to try this 3 here and see what happens. And it's sort of close to the middle. I mean, I guess you could pick 2 or 3. Let's see. That's 21. 7 times 3 is 21. 3 times 2 is 6. Plus 2 is 6, 8, 80. Oh, 81. I'll be darned. I got lucky. Because if I didn't get the 3, then I would tell me, well, if it's too big, I would go this way. If it's too small, or go something like that. Yeah. So 81's it. So 3 is it. So the answer is, dun, dun, dun. Let's see here. 5 too high. 3 is just right. 3. The volume is 3 what, though? 3 cubic centimeters. That means we need 3 of these things that each have, we're measuring out. See, this has 27, this has 27, and if you put them right next to each other, I guess, because that's what we're looking at, this has 27. I know that's not perfect. You have to use your imaginations here. I'm drawing this on the spot. All right. Oh, this might be better. 27 here, 27 here. It's getting messy. And so basically we're looking, there we go. That's probably better. 3 27s equal, what did we say? Oh, 81. 81 tiny little 1/3. Power of canceling. Here's a great tip. We'll turn this into the next video if you want to see this. Join us on part 3 of volume packing edge lengths, fractional edge length cubes into rectangular prisms.